The turbulent forces on Betelgeuse's surface paint a picture of relentless chaos. Enormous regions in its outer layers glimmer with brightness before fading again over merely a few weeks. A shockingly quick tempo for a star of such immense proportions. With a radius approximately 1,400 times that of our Sun, Betelgeuse is expected to change only over years or centuries. These fast-paced fluctuations defy those expectations, compelling astronomers to rethink how such giants behave. Scientists now observe colossal convection patterns, monster-like currents moving hot material from Betelgeuse's interior to its surface. Some of these convection cells span distances larger than Mars' orbit and shift unpredictably, collapsing and reforming in a cosmic flux. When these cells collapse or erupt, they can hurl tremendous amounts of gas and dust into space. From Earth's vantage point, these explosions obscure light, causing sudden dimming across vast sectors of the star. In some instances, one hemisphere fades dramatically, only to brighten weeks later as the dust clears, an activity so intense that researchers describe Betelgeuse's outer region as engulfed in stellar upheaval. This extreme volatility has sparked an intense dialogue within the astronomical community. One group believes these recent surface anomalies are harbingers of the star's final eclipse, an imminent supernova. According to this view, Betelgeuse's core has moved into the realm of heavier fuel fusion, elements like silicon and iron. Since iron fusion doesn't produce net energy, the core cools and collapses under its own gravity. This core implosion then rebounds, detonating the star in a catastrophic explosion that briefly rivals entire galaxies in brightness. Proponents of the supernova scenario argue that the dramatic dimming events align with theoretical markers of a star in its ultimate countdown. If this interpretation is correct, we may soon witness a celestial phenomenon of historic scale. A supernova bright enough to outshine the full moon could dominate Earth's sky, even visible during daylight, an occurrence humanity hasn't seen in over 4 centuries. Yet, a substantial number of astronomers remain cautious. They suggest that while Betelgeuse is undoubtedly nearing the end of its stellar journey, the observed outbursts may instead represent a drawn-out, unstable phase rather than an immediate prelude to explosion. From this perspective, the star could continue cycling through periods of upheaval and recovery for decades, or even centuries, before succumbing to gravitational collapse. This cautionary stance highlights how little is understood about massive red supergiants. Until James Webb's intervention, our observational tools couldn't unveil these dramatic processes in such detail. We might now be witnessing phenomena common to late-stage giant stars, phenomena that simply went unnoticed in the past. In other words, Betelgeuse's behavior may be turbulent yet routine for a star in this evolutionary stage. So which is it? Is Betelgeuse on the verge of exploding, or is it enduring a particularly chaotic chapter in its long life cycle? Regardless of the outcome, this moment is invaluable for science. These observations provide a rare chance for astronomers to refine their models of stellar evolution. Whether it be a legendary final act or a temporary bout of instability, Betelgeuse is teaching us new truths about the demise of massive stars. Some researchers even propose that Betelgeuse may be gradually stabilizing after the recent turmoil. While the star's appearance remains intense and dramatic, it might settle into more familiar patterns typical of a star in its last million years. But perhaps the most striking aspect of the Betelgeuse story isn't the theories, the predictions, or even the dramatic dimming events. It's the image itself. The high-resolution snapshot captured by the James Webb Space Telescope stands as a visual revelation. This isn't just another stellar photograph. It's a window into violent, unpredictable cosmic activity. Instead of a smooth, symmetrical sphere radiating consistent light, Betelgeuse appears as a wild, unruly titan, with its surface engulfed in colossal convective flows, hot spots, and massive plumes of gas. What the telescope revealed was not a quiet star nearing the end of its life in a graceful, fading glow, but a fiery giant in the throes of chaos. This single image has done what volumes of theoretical models could not. It has forced astronomers to reevaluate long-standing beliefs about how massive stars behave in their twilight years. For decades, Astrophysics textbooks have outlined a somewhat tidy end-of-life sequence for stars like Betelgeuse: burn through fuel, swell into a red supergiant, collapse under its own weight, and then explode in a supernova. But the Webb image shatters that tidy narrative. It suggests that this transition from supergiant to supernova might not be neat or sudden. Instead, it may be prolonged, erratic, and far more tumultuous than scientists once imagined. This visual evidence has stirred both excitement and unease in the scientific community. If Betelgeuse is not following the expected script, what other stars might behave similarly? How many of our stellar life cycle models are oversimplified or incomplete? The telescope's image challenges not only what we thought we knew about Betelgeuse, but also our broader assumptions about the life and death of stars across the cosmos. In many ways, it represents a seismic shift in our understanding, one that may take years, if not decades, to fully unravel. Yet beyond the science, the potential of a Betelgeuse supernova carries a deep emotional and philosophical significance for humanity. This isn't just a celestial event. It's a possible shared experience on a cosmic scale. Should Betelgeuse explode during our lifetime, it would become one of the most visually dramatic spectacles the modern world has ever seen. A supernova that close would be bright enough to be visible even in the daylight sky, possibly for weeks. It could rival the brightness of the full moon at night, illuminating landscapes and casting shadows with its radiant energy. The emotional impact of witnessing such an event would be profound. In an age dominated by screens and digital distractions, a Betelgeuse supernova would refocus human attention on the night sky, reminding us of the vastness beyond our planet and our small but meaningful place within the universe. It would not just be an astronomical occurrence. It would be a cultural moment, inspiring wonder, curiosity, art, and reflection. More than that, watching a star like Betelgeuse die would give us a rare look into the universe's most fundamental process: cosmic recycling. A supernova is not merely an end, it is also a beginning. When massive stars explode, they don't vanish into nothingness. Instead, they release vast quantities of material, carbon, oxygen, iron, silicon, into the interstellar medium. These elements become the building blocks of future stars, planets, and even living organisms. In fact, the very atoms that make up our bodies originated in ancient supernovae. The oxygen we breathe, the calcium in our bones, the iron in our blood, all were born in the hearts of stars that exploded long before the Earth ever formed. In this sense, to witness Betelgeuse go supernova would not just be to observe a dying star, but to see, in real time, the process that once created us. It would be a vivid, glowing reminder that the cosmos is not distant or detached, but intimately connected to our existence. This understanding lends the potential event a kind of poetic beauty. As we stare into the fiery death of a distant sun, we are also looking into our own origins. The universe, in its grand cycles of destruction and rebirth, reminds us that even in apparent endings, there are beginnings waiting to unfold. Just as Betelgeuse's eventual collapse would scatter the seeds for future cosmic formations, our own lives and civilizations are part of an ongoing story written across time and space. In this way, the image of Betelgeuse becomes more than just data. It becomes a symbol, a testament to the power of human curiosity and the tools we've built to satisfy it. Through instruments like the James Webb Space Telescope, we are not just observing stars. We are discovering pieces of ourselves. Every pixel in that image tells a story of thermonuclear fusion, elemental creation, and eventual transformation, forces that have shaped not only stars, but life itself. So while we wait to see whether Betelgeuse's brilliant end will unfold in our lifetimes, we already have something extraordinary, a glimpse into the nature of stellar life and death, captured in unprecedented detail. It's a reminder that the universe is a place of constant motion, unpredictability, and wonder. And it challenges us to keep looking up, not only in search of answers, but in appreciation of the mysteries still waiting to be discovered. Because in the end, the significance of Betelgeuse's image isn't just about what it shows. It's about what it inspires: awe, humility, and the enduring human drive to understand our place in the cosmos. Every single atom of iron coursing through your blood, Every atom of carbon that forms the intricate patterns of your DNA was forged in the heart of an ancient star. These stars, much like Betelgeuse, lived for millions of years before ending their lives in colossal explosions known as supernovae. In the aftermath of these explosions, essential elements were scattered across space, enriching clouds of gas and dust that would eventually coalesce into new stars, planets, and ultimately, life itself. This cycle of cosmic birth and rebirth means that we are, quite literally, made of stardust. In this way, the ongoing story of Betelgeuse is not a distant astronomical curiosity. It is a deeply personal one. It ties us to the universe, serving as a humbling and beautiful reminder that the very materials we're made of were once part of stellar giants. The James Webb Space Telescope's extraordinary view of Betelgeuse offers more than a snapshot of a dying star. It provides a portal into our shared cosmic heritage. Yet, as awe-inspiring as this image is, it represents only the first chapter in a much broader tale of exploration. Webb's advanced instruments are revealing parts of the universe we've never seen before, from nascent galaxies formed shortly after the Big Bang to potentially habitable exoplanets orbiting distant suns. Each image it beams back expands our understanding and deepens our sense of wonder. As we continue to receive new data, we're not just compiling knowledge, we're actively uncovering the hidden architecture of reality. In doing so, Webb is more than just a telescope. It is a time machine, a philosopher's lens, and a bridge connecting us to the farthest reaches of space and time. Ultimately, Betelgeuse is more than an object of scientific curiosity. It is a cosmic ambassador, urging us to question, to observe, and to explore. What we witness today may be a climax, or it may simply be another act. But one certainty remains. The universe has delights and mysteries beyond our wildest imaginations, waiting, ready to astonish those who dare to look.